Hello friends! Power electronics market is huge and goes way beyond our planet, and I'm very excited that we all are part of it. So let's see, what is new in power semiconductors industry? As a market and technology leader for metallized ceramic substrates, Rogers has quickly identified the opportunity to unleash the commercial and technological potential of innovative products. Rogers is now capable of delivering silicon nitride active metal braze substrates with improved thermal performance to its broad customer base. While the final qualification is ongoing, first samples are already available for customer evaluation. Furthermore, thermal simulations can be performed to understand the substrate's potential benefits for target applications. This could be interesting particularly for silicon carbide modules because silicon carbide devices are much more expensive than their silicon counterparts and are therefore the main cost driver for the modules. Besides, silicon carbide technology is likely to make significant progress in the coming years. One can expect new generations of smaller chips with a lower specific on-state drain-to-source resistance to come to the market very soon. In this case, the higher thermal conductivity of the ceramic can compensate the smaller chip area. Littelfuse, an industrial technology manufacturing company empowering a sustainable, connected, and safer world, announced the expansion of its silicon carbide diodes portfolio to include the 1700-volt class. The new series silicon carbide Schottky diodes are available in a TO247 2L package with a choice of current ratings up to 50 amps. They offer power electronic system designers a variety of performance advantages, including close to zero reverse recovery current, high surge capability, and a maximum operating junction temperature of 175 degrees, so they are ideal for applications that require enhanced efficiency, reliability, and simplified thermal management. In a race to reduce aircraft emissions, developers increasingly are moving toward more efficient designs, including electrical systems that replace today's pneumatics and hydraulics, powering everything from onboard alternators to actuators and auxiliary power units. To enable next-generation aircraft electrical systems, new power conversion technology is required. Microchip Technology announced its development with Clean Sky, a joint European Commission and industry consortium of the first Aerospace-qualified baseless power modules enabling higher efficiency, lighter, and more compact power conversion and motor drive systems. Partnering with Clean Sky to support aerospace industry goals set by the EC for stricter emission standards that result in climate-neutral aviation by 2050. Microchip's BL1, BL2, and BL3 family of baseless power modules provides greater efficiency in AC to DC and DC to AC power conversion and generation through the integration of its silicon carbide power semiconductor technology. Electromobility is fast becoming a reality. In fact, every science car produced today is operated on a form of electrification. Demonstrating the power and convenience of an electric vehicle, Volkswagen of America has teamed up with long-distance driving expert Rainer Zittlau for the Volkswagen ID4 USA Tour that recently kicked off at Volkswagen of America's headquarters. Infineon Technologies, a world leader in semiconductors for mobility, energy efficiency, and the Internet of Things, is on board of the new Volkswagen ID4 with over 50 semiconductors enabling energy-efficient electric drives and charging infrastructure. Moreover, the drive route of the Tour, which will be crisscrossing the United States, will incorporate 5 Infineon facilities. Geely Automobile Company, a leading Chinese automobile manufacturer, and ROHM, a global semiconductor manufacturer, are strategically involved in advanced technological development in the automotive field. Geely and ROHM began technical exchanges in 2018 and have collaborated on the development of various in-vehicle applications. This partnership will further promote the fusion of the two companies and accelerate technological innovation in the automotive field. Geely leverages ROHM's advanced power solutions centered on silicon carbide power devices to develop highly efficient traction inverters and in-vehicle charging systems to extend the range of electric vehicles, reduce battery costs, and charge time. At the first result, a traction inverter equipped with ROHM's silicon carbide power devices was adopted for the platform for electric vehicles currently under development by Geely. The space race is heating up, with Richard Branson's Virgin Galactic and Jeff Bezos' Blue Origin have recently launched their first space flights. While these new space companies are making headlines, old space organizations such as government agencies and large traditional aerospace companies continue to push the boundaries of outer space. All space-related transport and instruments require highly reliable power solutions designed specifically to withstand the harsh environments necessary for space applications. Gallium nitride-powered systems revolutionize capabilities in propulsion systems to meet challenges in high-power, high-density motors, avionics systems and subsystem point-of-load converters, and aerospace power and energy storage for power conversion and control, distribution, and transmission. GaN systems power transistors deliver the efficiency, size, and power density benefits required for demanding high-rail power applications. NASA is developing Europa Clipper, an interplanetary mission to conduct detailed reconnaissance of Jupiter's moon Europa and investigate whether it can harbor conditions suitable for life. For this mission, NASA's Jet Propulsion Laboratory will need various instruments to collect and measure critical data while the spacecraft is in orbit. The organization has shifted away from silicon toward gallium nitride technology for the essential components that power these activities, due partly to the reduced cost per pound enabled by gallium nitride. GaN systems transistors have delivered impressive results for NASA and will be used for the Europa Clipper project. Transphorm, a supplier of gallium nitride power conversion products, has closed on the transaction for the acquisition of 100% interest in the company's AFSW Wafer-Fab facility by GaN Aviation, Transphorm's recent joint venture with Palo Alto-based JCP Capital, a new strategic financial partner. This is a big step forward for Transphorm and its existing AFSW wafer fabrication facility, previously a joint venture with Fujitsu Semiconductor Limited, located in Aizu, Wakamatsu, Japan. The facility is a premier wafer manufacturing fab for high-quality, reliable, high-voltage gallium nitride power semiconductors. Macronix International, a leading integrated device designer and manufacturer in non-volatile memory, and Hon Hai Technology Group, Foxconn, the world's largest electronics manufacturer and service provider, announced the signing of an asset transaction agreement for the sales of Macronix 6-inch wafer fab and equipment in Hsinchu Science Park to Foxconn for $2.52 billion new Taiwan dollars. The transaction is expected to be closed by the end of 2021. The acquisition of the 6-inch wafer fab in Hsinchu Science Park officially signals Foxconn's entry into manufacture and development of wide bandgap semiconductors, especially silicon carbide, paving the way for a long-term commitment to semiconductor development. The manufacturing of silicon carbide is in line with Foxconn's 3+3 strategy: electric vehicles, digital health, robotics, plus artificial intelligence, semiconductor, and advanced communication. That's it for today. Thanks everyone for watching. As usual, more market updates are coming next week. Meanwhile, go to Market Insight website for more information or join me in social media. Keep in touch.